So let us look at the first question. It's an example 1 in the chapter. The question is, are the following statements true or false? Give reasons for your answers. The first statement is, every whole number is a rational number. So let us look at whether it is right or not. So every whole number is a rational number. That's the question. The question we have to understand is that if you pick any whole number from the collection of all the whole numbers, will it be a rational number? So to understand how to answer this question, we can actually use some examples and try to check whether the statement is correct or not. And basically, if we have to prove something is wrong, all we need is one single example. Once more, if we have to prove something is wrong, all we need is one single example. So let us look at the number 0. Is 0 a whole number? Answer is yes. We can now ask another question. Is 0 a natural number? Answer is no, right? So the overall answer to this question is it is false. Okay? So if we had taken any other number, let's say number 1, then it is both a natural number and a whole number. But the question here is every whole number. We have whole numbers starting from 0, right? So the question is every whole number. If you still have some doubt, let us see what is a set of whole number. Whole number we know is denoted by W. Now the number starts from 0, 1, 2, 3 and it goes all the way up till infinity. Now 1, 2, 3 till infinity is a natural number, but 0 is not a natural number. 0 is a whole number, but it is not a natural number. Thus, we cannot say that every whole number is a natural number. Now we go to the next question. The question here is, every integer is a rational number. To understand this, let us write the set of integers. Set of integers is denoted by the letter Z, and the integers start from negative infinity and it has all the negative numbers and it also includes 0. It has also all the natural numbers and it goes all the way up to positive infinity. Now the question here is, every integer is a rational number. Is it so? Let us pick an integer like -2. Now -2, we can write it as -2 by 1 and it is a rational number. You can take anything. Let's take 0. 0 can be written as 0 by 1. So it is also a rational number. Thus any integer that we take from the set Z, we can always write it in the form of a fraction. In other words, it is a rational number. Thus the answer to the question is yes, it is a true statement. Okay. And the third question is, every rational number is an integer. Let us write the list of rational numbers. It is denoted by the letter Q. It starts from negative infinity and let us write a rational number as -7 by 2. Okay. Then we have -1, we have 0. Let's say we write 2 by 3. Okay. And then let's say we write 9 by 2. And then we have 7. Let us also write some prime numbers and it goes all the way up till infinity. The question is, every rational number is an integer. So let us pick any rational number. Let us pick this example, or let us pick 2 by 3. Now, is 2 by 3 an integer? Is 2 by 3 an integer? The answer is no. 2 by 3 is not an integer. 2 by 3, it is a rational number. It is correct, but it is not an integer. Why? Because integers are complete units. Okay, that is the reason. Thus, the answer to the question every rational number is an integer, this statement is false. Now let us look at the example 2, that is find 5 rational numbers between 1 and 2. And in the textbook you can see that we can approach this problem in at least 2 ways, or 2 methodologies have been provided. We will look at both these methods and we will try to understand which is better and which will lead us to having simpler calculations. Let us look at the solution 1. So in the textbook it says that we can approach this problem in at least 2 ways. We will look at 2 such ways as described in the textbook. So in solution 1, to find a rational number between r and s, you can add r and s and divide the sum by 2. So how do we write it? So when you write it, what we get is r plus s by 2, and what will be this value? This value, right? Whatever this value is, we know it depends on r and s, and this value will lie between r and s. So in the current question, we have r equal to 1 and s equal to 2. So in a number line, let's say we have 0 here, we have 1 here, we have to find 5 rational numbers between 1 and 2. Let us find the first rational number between 1 and 2. So r plus s by 2, we can write it as 1 plus 2 divided by 2, and this will come to be 3 by 2 or equal to 1.5. Before we find the other 4 rational numbers, let us try to note it down on our number line. Okay, now what will be the position of 1.5? It will be between 1 and 2, and it will be exactly between 1 and 2. So now that we have marked 1.5 on the number line, let us find the next 4 rational numbers between 1 and 2. Now we can take 1 and 1.5 as r and s, and we will try to find a rational number. So any number between 1 and 1.5 will also lie between 1 and 2, right? So we take 1 plus 1.5 by 2, and that will come to be how much? We can write it as 1 plus 1.5. We can write it as 1 plus 1.5, or I can write it as 3 by 2 whole divided by 2, and then if you calculate, this will come to be 5 by 4, and 5 by 4, if you actually calculate, it will come to be 1.25. As I said before, this 1.25 will come to be exactly somewhere here. This 1.25 will come to be exactly between 1 and 1.5. For the third rational number, again we can take 1 and 1.25. So any number between 1 and 1.25 will also be between 1 and 2. So I take 1 plus 1.25 divided by 2, or 1 plus 1.25, and 1.25 is nothing but 5 by 4 whole divided by 2, and if you calculate, you will get 9 by 8, which is 1.125. How do we represent this 1.125? So 1.125 will come exactly between 1 and 1.25. Let us try to mark 1.125 will be exactly in the middle of 1 and 1.25. We have got 3 numbers. How do we find the fourth number? I can continue the same way. I can choose, you can go with 1 plus 1.125 whole by 2, which is nothing but 1 plus 9 by 8 whole by 2, and that will be 17 by 60. So if we actually calculate, it will come to be 1.0625. Now 1.0625 or 17 by 16, this value will come to be exactly between, I will now change the color to a different one for showing 17 by 16 on the number line, and that will be somewhere here, right? So we can go on, continue to do it, but what you can see, when we started this process of finding the rational number between 1 and 2, first we got 1.5, then we got 1.25, then we got 1.125, and finally we got 1.0625. So more and more numbers are coming into this region, right? Let us choose R and S as 1.5 and 2. So we have this entire region not utilized. Okay, so let us change the values of R and S as 1.5 and 2. So we can write it as 1.5 plus 2 by 2. And what you will get is 3 by 2 plus 2 whole by 2, right? What you will get is 7 by 4, and this value will come to be 1.75. So where will this value come? This value will come to be somewhere here. Okay, if I mark it, I will get it here. This will be 1.75. So we have now all the numbers. We have the first rational number, second, third, fourth and fifth. All will lie between 1 and 2. Now let us look at it. How can we put ourselves in so much of trouble doing this simple calculation? So in this process of calculating R plus S by 2, I have always tried to ensure that at least R or at least S is as simple as possible. In this case, 1 is a simple number, 1 is a simple number, 1 is a simple number, here 2 is a simple number. So only on one side we have slightly complication or slightly difficult numbers to calculate. Let us look at the case of finding the correct answer in a very difficult manner. It all depends on the choice of our R and S. Okay. Now let us say you are trying to solve this problem and you calculated the first value 1.5 and then 1.25. Instead of going with the simpler R, you chose R and S as 1.5 and 1.25. Now how this will become? So R plus S by 2, now you chose a difficult calculation. 3 by 2 and 5 by 4 as R and S. So you will have 3 by 2 plus 5 by 4 whole divided by 2. Now you know it is not an easy calculation. You will have more multiplications required to calculate this. So if you actually calculate it, you can calculate like 4 into 3 plus 5 into 2, okay, divided by 16, you will get it. So actually, if I actually write, you will have 4 into 3, 12 plus 5 into 2 divided by 4 into 8, 8 into 2, 16, you will have 22 by 16, and it is not in the simplest form. You can write it as 11 into 2 by 8 into 2, and that will and that will become to be 11 by 18. Is this a correct answer? It is a correct answer, okay? But the kind of steps that we have to proceed with is slightly difficult. We can always choose a simpler R or S value and make our life much easier. We can get the correct answer with the least amount of time and least amount of calculations. Now, where will this 11 by 8 fall into the number line? So 11 by 8, I will change the color of 11 by 8, and 11 by 8 will fall somewhere here. So let us find one more point between 1 and 2, and now we will choose a point between 1.5 and 1.75. So that will become 3 by 2 plus 7 by 4 divided by 2. And now let us calculate. You will get 4 into 3, 12, plus 7 into 2, 14 divided by 6, and this will come to be 26 by 16. Let us factorize 26 by 16 and we will get 13 by 8. So in the textbook for the same problem, you will see the solution coming as 5 by 4, 11 by 8, 13 by 8 and 7 by 4 along with 3 by 2. I just showed you here that 13 by 8, how difficult it is to get into. We can go with a simpler choice of R or S and do the calculations much faster. We need not calculate all these decimal numbers at this moment. I have calculated this just for you to have an understanding of how these numbers are in the decimal form. Okay, it is always complete numbers. Now it is your choice how you want to solve the problems. One way is that we choose R and S as simple values, at least one of the value as simple value, and continue to calculate. Let's say you tried, it started with 1 and 2, you got 1.5, and then you go with 1.5 and 2, you will get 1.75, and then you chose 1.5 and 1.75, you will get somewhere here, and you continue to do it, but it will be slightly tougher calculations. We now try to solve the same problem in the second method, which is described as solution 2 in the textbook. A different way is to find all the 5 rational numbers in one single step. So if we want 5 rational numbers, and so we write 1 and 2 as rational numbers with the denominator 5 plus 1. I will come again. We will now try to represent the two extreme R and S, which is here 1 and 2, as a rational number with the denominator 5 plus 1. Now we have a number line and I'm just showing the 3 points 0, 1 and 2. We have to find the rational numbers between 1 and 2. Now the question will become, how did we get this 5 plus 1? How we arrived at this 5 plus 1? So let us come back to the number line where I have shown 0, 1 and 2. Now we have to find 5 rational numbers between 1 and 2. Okay. So the first thing is that we represent the two extreme numbers in the form of a rational number. 1 is same as 1 by 1. Okay. It is also as same as 2 by 2. It is also same as 6 by 6. Again, let us look. 2 is same as 2 by 1. It is same as 4 by 2. And it is same as 8 by 4. also same as 12 by 6. Now let us look at 6 by 6 and 12 by 6. One is same as this, and 12 by 6 is same as this, and 2 is same as this. We have to find 5 rational number between these two. Now it is very easy, much easier than the previous method. We just have to write 6 by 6. Next we write 7 by 6. Next we write 8 by 6, 9 by 6, 10 by 6, 11 by 6, and 12 by 6. So what we have done here, we just from 6 by 6 we only take the numerator and we add 1. We continue to add 1 and then we will get till 2. So we have 1, 2, 3, 4, 5, 5 rational numbers between 6 by 6 and 12 by 6. When we come back, how did this 5 come? Because we required 5 rational numbers, we add 1. This adding 1 is a procedural step. So now we have found all the 5 rational numbers between 1 and 2. Come again, the question here would be, how did we get the denominator, right? How did we arrange this 1 to 6 by 6? So in this problem, we wanted 5 rational numbers. So for that, what we do is that we take the first number, that is 1 here, and what actually we are doing is that we are multiplying by 5 plus 1 and dividing it by 5 plus 1. So we are multiplying the number 1 with the same numerator and denominator. So it is same as 1. Now how are we calculating this 5 plus 1? So this 5 is the number of rational numbers that we want between the two numbers, and we are adding plus 1 to get the correct fractional form. Same way the other number, what we do is to take 2 and then we multiply by 5 plus 1 and divide by 5 plus 1. Again we are multiplying 2 with the same numerator and denominator. And this 5 comes from the number of rational numbers that we need. Note, these numbers are not in its smallest form, but that is okay. It is still a value between 6 by 6 and 12 by 6, or 1 and 2. If you want, you can factorize it to the smallest form. Let's say 8 by 6, we can write it as 4 by 3, right? 8 by 6, if you divide both the numerator and denominator by 2, you will get 4 by 3. Similarly, 9 by 6 can be written as 3 by 2, right? So 9 by 6 is same as 3 by 2. So one thing that we can learn from this example is that if you take any two number, let's say 0 and 1, we can find infinite number of rational numbers between 0 and 1. It is possible. We have just found 5 rational number between 1 and 2. Can we find 10 rational numbers between 1 and 2? How do we find 10 rational numbers between 1 and 2? So in general, there are infinitely many rational numbers between any two given rational numbers. So in our example, we have taken 1 and 2 as the two numbers, and we wanted to find 5 rational numbers between 1 and 2. But through this exercise, what we also understand is that it is not just 5. We can find any number of rational numbers between 1 and 2. Let's say we want to find 10 rational numbers between 1 and 2. Now how do we do that? With the same example, what we can do is that instead of transforming 1 in the form of 6 by 6 and 2 in the form of 12 by 6, we do it in a different way. What we do? What we do is to take 1 and we multiply it by 10 plus 1 and divide by 10 plus 1. And we want to find the numbers between 1 and 2. And the last number is 2. 2, we will transform it as 2 into 10 plus 1 divided by 10 plus 1. So let us calculate it. What will this come to be? This will come to be 11 by 11, and we want to find numbers between 1 and 2. The other number will become how much? 2 into 10 plus 1, right? So that will become 22 divided by 11. Now how can we write the 10 rational numbers between 1 and 2? See, this is 1, right? 11 by 1 is 1. 22 by 11 is 2. All we need is to write 11 by 11, 12 by 11, 13 by 11, 14 by 11, and like that it goes. 20 by 11, 21 by 11, and 22 by 11. So if you write all the numbers between this range, you will get 10 rational numbers, all falling between 11 by 11 and 22 by 11. So this emphasizes our point that we can find infinite rational numbers between any two rational numbers. Once again, I will repeat, through this exercise we can understand that we can find any number of rational numbers between any two numbers. All we have to change is this particular number. If you wanted 20 rational numbers, we will do 1 into 20 plus 1 divided by 20 plus 1. If you want to find 20 rational numbers between 1 and 2, what we do? We will do 1 into 20 plus 1 divided by 20 plus 1, and divide the other side. We'll do 2 into 20 plus 1 divided by 20 plus 1. So on a number line, you can take any 2 points. You can always find infinite number of rational numbers between the two. Once more, you take any 2 points on a number line, you can find infinite rational numbers between the two. So let us now ask ourselves this question, that if I continue the process of finding the rational numbers between any two given rational numbers, will there be any number left? So right now we found 10 rational numbers between 1 and 2. Let's say we found 20 rational numbers between 1 and 2. Then we try to find 50 rational numbers between 1 and 2. Then we try 100 rational numbers between 1 and 2. And let's say we continue the process. We will find 1 lakh rational numbers between 1 and 2. Then we will find 10 lakh rational numbers between 1 and 2. We will continue to do this. Let's say we find 1 crore rational numbers between 1 and 2. Okay. Let's say we found 1 billion rational numbers between 1 and 2. Okay, like this we can continue the same process. Let's say we find 1 trillion. Okay, like that we continue. Now the question here is that if we continue this process of increasing, more and more numbers we are trying to find, If we continue the process of increasing more and more we are trying to find, will there be any number left? That's the question. Will there be any number left between 1 and 2? The answer is yes. There will still be numbers between 1 and 2 even after finding all the rational numbers between 1 and 2. Such kind of numbers we will study in the next sections.